All right, let's put what we have learned about trigonometry into practice. What we're going to do is read through a problem, and then we will have to consider the situation, potentially draw a picture, and then decide which trig function we need to use to solve this problem. Now, before we start, let's just review really quick our acronym SOHCAHTOA, which does give us those trig functions in a helpful way. So remember, sine is the ratio of the opposite over the hypotenuse. Cosine is the ratio of the adjacent side to the angle over the hypotenuse. And tangent is the ratio of the opposite side over the adjacent side. So, for example 1 here, it says a skateboard ramp is 12 inches long and rises from the ground at an angle of 17 degrees. How long is the base of the ramp? So we can imagine a skateboard ramp as simply a triangle like this. We want a right triangle. Okay, now it says it's 12 inches long, so that would be the hypotenuse, and it rises from the ground at an angle of 17 degrees. So we can draw our picture like this, and then we have to decide which function to use. Now it says how long is the base of the ramp? So that would be this side here. Well, from our angle, we have the hypotenuse and we have the adjacent side. So we need to use cosine. So we can set up our function equation. The cosine of 17 equals, and cosine is adjacent over hypotenuse, so x over 12, which means to solve it, we would do times 12 on both sides. And so our answer would be cosine of 17, which is 0.9563 and on, times 12, which is 11.475. So I'll call that 11.5 inches. And there we go. Let's look at example B. An escalator in a subway station has a vertical rise of 195.8 feet. So we have a triangle here. Here's our escalator. A vertical rise of 195.8 feet. Rise is at an angle of 10.4 degrees. How long is the escalator? Okay, so from our triangle, from the angle we've got the hypotenuse on the opposite side. So we'll use sine here. The sine of 10.4 is equal to 195.8 over x. And if you remember from our notes before, we can think of this as a proportion, and then we'll do 1 times 195.8 divided by sine of 10.4. So 195.8 divided by the sine of 10.4 gives us 1,084.65 feet. And I'll call that 1,084.7. Okay, example C. Grove Street rises 20 feet for every 100 feet of horizontal distance. So if we have 100 feet of horizontal distance, we rise 20 feet for that. So there's our Grove Street. At what angle does Grove Street rise? So this angle here is what we're trying to find. Okay, so from that angle, we have opposite and we have the adjacent. We don't know the hypotenuse, but that's okay. We can use the tangent function. Now, because we're missing the angle, we will end up having to use, so it's opposite over adjacent, we will end up having to use the inverse function of that ratio to find our angle. So 20 over 100, and then we'll do the inverse tangent, and we get 11.3 degrees. Okay, so sketch a triangle based on your problem, and then determine which trig function or inverse function you'll need to use. Some terms to keep in mind are the angle of depression and angle of elevation, which may be used in problems like this. So the angle of depression is an angle that goes down. You can think of this as down from the sky, because often that's the context that we use angle of depression. It's something looking down, brings you down. So that would be this angle here, the angle of depression. It's the angle that we're looking down. And for the angle of elevation, you can think up from the ground. And that would be the angle here if we're rising up towards something. Now, the thing about these two angles that you need to keep in mind is that they are the same. If we can think of the sky line and the ground line as parallel, that means that we have a transversal, this dotted line here. So these angles are equal. These angles are congruent. Okay, so the angle of depression for a situation will equal the same angle of elevation if thought of from the ground. These are alternate interior angles. So, for example, D, it says a child is looking at a bird on top of a flagpole that is 53 feet away from her. So if we have a flagpole here, like this, there's a bird up on top. I'm not going to draw a bird, but we can imagine it being right here. A child, put a little stick figure here, is looking at a bird on top of a flagpole that is 53 feet away from her. So we know that this distance here is 53 feet. The flagpole is 100 feet tall, and her eyes are 3 feet above the ground. So this is giving us some additional context about the triangle. So if we have our triangle starts at her eyes, and that's important because if the flagpole is 100 feet tall, we're starting 3 feet above the ground. So we have a 97 here for the edge of our triangle. So we have 53, 97, and we're trying to find the angle of elevation, which would be this angle right here. Okay, so we'll need to use an inverse trig function. We have from our angle the adjacent and the opposite sides. This would be the adjacent side. This would be the opposite side. We don't have the hypotenuse. So we'll use tangent, and we're going to use an inverse tangent function. So this is very similar to example C up here. It's just a little bit different context. So we know that the tangent of this mystery angle is 97 over 53. So we need to use the inverse function of that ratio of opposite over adjacent. So 97 over 53 is going to give us 1.8301, etc. We'll take the inverse tangent of that and get 61.3, we'll call that. So she's looking up at that bird at a 61.3 degree angle. Okay, at 11,500 feet, a pilot begins landing her plane at a 3-degree angle of depression. How far away is the runway? So let's sketch a little picture here. Here's the ground. Here's the sky, or the elevation of the plane. I guess I'll draw a plane, or my best attempt at one. Here's a plane. We're at 11,500 feet. So that is the distance here, 11,500. We're landing at a 3-degree angle of depression. And remember, that's this degree here. That's the angle from the sky to our landing, our dotted line. So that means this other angle down here is also 3 degrees. We want to know how far away is the runway. So we're looking for this distance here. So from the plane's location to the runway, we're looking for this horizontal distance. So we'll call this x down here. So from our angle right here, we have the adjacent and we have the opposite. So we'll again be using tangent because we don't know the hypotenuse. Now I could be persuaded that how far away is the runway could mean the hypotenuse here, which is how far the plane must fly. So we'll figure out both. First, we'll figure out this x here, which is what I assume the problem is looking for. But then we'll go ahead and also find the hypotenuse afterwards, just for fun. So we are going to use the tangent function. Tangent, let me do this in red. It's very important. Tangent of 3 equals opposite 11,500 over x. And remember from previous, we'll use a proportion. So we'll multiply 1 times 11,500 divided by the tangent of 3. So 11,500 divided by the tangent of 3 gives us 219,434.9 feet. Pretty far, but remember we're talking in terms of aviation here, how many feet a plane has to fly. Now, just in case, what the problem was actually looking for was the hypotenuse, the distance the plane has to fly, although I think it would have given that context in the question. It would have said, how far does the plane have to fly, or how far from the plane to the runway? But just in case, we'll find it anyway. So what we'll have to use here is the opposite over the hypotenuse, or the sine function. So if I want to find the hypotenuse, I'll say sine of 3 equals 11,500 over y. So I'll call this y. So I'll do the same work. I'll do 11,500 divided by sine of 3. Which gives me 219,734. Which is pretty close to what we got for the horizontal distance as well. Which, if you think about it, should make sense, because if we are 11,000 feet up in the air at a 3-degree angle, the difference between where we're flying on the ground versus in the air is not actually that much over that large distance, pretty close together. So just in case you interpreted that problem differently, you could have found the hypotenuse or the horizontal distance, but either way, there are your two answers. So for any of these problems, draw a picture. It will be a right triangle of some kind, and then determine which trig function you need to use, or the inverse function, to find what you're asked for in the problem.